Let us see this question and we'll solve it. The question is a uniform massless spring, zero, mass is zero. If extended or compressed, distance between every two consecutive turns, that is called pitch, changes by the same amount. A spring obeying this property and Hooke's law is called a linear spring. So this spring is a linear spring. So let us first learn about this part. What does it want to tell? It tells you that you have a linear spring like this. The distance between each turn is called pitch. Let's say, and it is same for all. Pitch is P naught. Let us say P naught. So all will be P naught. Our case is talking about stretching, so we will go on stretching. Now, suppose this length of the spring was unstretched length L naught. That is also called, unstretched is also called the natural length. So if it is L naught, now this spring has been stretched. So the gap between each turn, that initial was P naught, has increased by delta P naught. Each term gap will be increased by delta P naught. Hence it is equal. So such kind of spring is called the linear spring and it obeys the Hooke's law. So Hooke's law you must be knowing, if a spring of length, natural length L has been increased by a length of delta L, then the force exerted by the spring will be K into delta L, where K is the spring constant. So this concept you understood. Let us go to part A. Spring, the relaxed length L naught is equal to 30 centimeter. Natural length, relaxed length are the same thing. So that is given. Means your L naught is given. It is attached at one end to a wall. Here it is attached. And this is, as per question, is L naught. If the other end is pulled away from the wall with a force F, so this pull is done by applying a force F. And the value of F is given 60 Newton. So F also is known. Pth turn, that is sixth turn from the wall, reaches a position where qth term, fifth turn of relaxed spring was. Due to this force, the spring started stretching, and it will keep on stretching till the time the external force is balanced by the spring force. So net force on the spring end will be zero. So spring will be zero. At that time it will stop in stretching. It will cease to be stretching. So pth turn is known to you and qth turn is known to you from the question. So let us solve this. We have made this diagram where it has been shown that pth term from the wall as per question, this one, this much, from here to here, the green arrow, when it was stretched by force F, and after stretch the total spring has in its length has increased by delta L naught. So this is the condition in stretch condition. Okay, so this pth turn has taken the place of qth turn. Means after stretching, this pth turn has come to this position. So this length which was before stretch has now become this much. So in the spring which obeys the Hooke's law, the strain on any section of the spring, means any length of the spring, whether you take this length or this much length or this much length, strain will be equal. And how do we define strain? Stretch in that section of the spring divided by the original length of that section of the spring. Suppose out of this spring you have taken AB. Okay, AB, this section you have taken. Another section you have taken AC, this section. So strain in this AB will be same or equal to the strain in AC. If you write change in delta AB after stretch divided by AB original length, change in AC divided by original length AC will be equal. So you can write like this. So let us focus on this problem now. What is the length of the pth turn from the wall? Initial length. Initial length of the pth turn section of the spring till peak turn, if we say as Pi, that was equal to the pitch. Suppose the pitch of that spring is P naught into number of turns. Number of turn is P. So this is the initial length. Final length after the stretch. For the section of the spring from the wall till pitch turn, if we write like PF, so you know the Q turn length, and that is equal to P naught by P naught into Q. So this is important to understand. As per questions, it is being said that P has taken the place of Q when the stretch is complete in this spring. So now this length has become equal to this length. But this length we already know from here, because initial pitch was P naught and there was Q turn. So P naught into Q. So if we write the change in length of the peaks of the section of the spring till peak length from the wall, delta LP, so that will be PF minus PI, P naught common, Q minus P. This is equation 1. So strain will be, strain you can write delta LP bar divided by LP, but LP was P naught into P. This is original length we are talking about. Let us write this as LPI. I think that would be better to avoid confusion. LPF, LPF, LPI. So this will be your LPI. So initial length, means natural length was P naught into P. P naught will cancel out. So strain in this section will become delta LP by LP initial Q minus P divided by P. And this one we will say equation 1. Now let us go for the total length of the spring. The total length has increased by delta L naught. So for the total length of the spring, strain will be equal to initial length was of the spring was L naught, that is original length. Sorry. Will be change in length delta L naught divided by the original length. Number 2. For the linear spring, these two strain will be equal. So equation 1 and 2 will be equal. So we can write Q minus P divided by P delta L naught by L naught. So your delta L naught will become Q minus P divided by P into L naught. This is your equation 3. Now you know that the stretch will continue till the time the total stretch in the spring that generates the force, spring force, that becomes equal to the external force. Means stretch will stop when, as per question it is given, external force is F will become equal to the spring force. So what will be your spring force? We have said that total stretch in the spring is delta L naught. So if K is the spring constant, so K into delta L naught will be your F. So K you can say F by delta L naught. From equation 3, if we put this value over here, the P will go up. So you will get the spring constant as this. F you know, P's turn is given, Q's turn is given, original length of the spring is given, so you will get the value of K. If you put the value from the question, F is 60 Newton, P is 6, Q is 8. Sixty into 6, Q is 8 minus 6, L naught is 30 centimeter. You will get the value. This is in centimeter. F is in Newton, so Newton meter per second square. So you will have to convert this into meter. So 60 into 6 into 100 divided by 2 into 30. 600 Newton per meter. If you want to write the answer in centimeters, you can change it to 100. Meter will become 100. If you want to write in centimeters, then meter will become 100 centimeter. That will come as 6 Newton per centimeter. This will be your answer for part A. Now let us go for part B. Part B is saying the ends A and B of a linear spring of relaxed length L0 are so pulled that the ends shift by distance delta LA and delta LB, which is shown here as well in questions figure. Find shift of a point on the spring that was at a distance L0 by n, where n is equal to 3 from the end A in relaxed spring. So in the question, it is being asked about a length L0 by n when the spring was relaxed. Means there is no stretch, means there is no extension, there is no compression. So when the spring was stretched, its end change, A point has shifted towards the left with a delta LA amount, and B point has shifted towards the right with delta LB. So what is the total change in the spring, change in length of the spring? If we say L0 is the original length L0 and we represent total change as delta L0, so total elongation will be in the spring delta LA plus delta LB. In this process, if we say that this P point has shifted a distance x towards the right overall from A reference point, from the point of reference of A. Initially, when it was unstressed, it was there. Now from A, it has gone to this point, and x is the rightward shift. So what is the total change in length of this section A to P? You can easily see A has gone this way, delta LA, P has gone this way, x. So this length has become now this much, and the total change in length is delta LA plus x. Okay. So if you say delta L0 by n, how much change has come in this section? This is L0 by n as per the question. So we can write it as delta LA plus x. So what will be the strain in this section AP? Your delta L0 by n and divided by its original length. Original length is L0 by n. What is the strain in total length of the spring? delta L naught by L naught. As per linear spring definition, these two will be equal. L naught by N, delta L naught by L naught. So delta L naught by N, delta LA plus X divided by L naught by N. And delta L naught is your delta LA plus delta LB divided by L naught. So your L naught and L naught will cancel out. From here you will get X as Nx is equal to N times delta LA 1 minus N plus delta LB. So your X will become delta LA 1 minus N plus delta LB divided by N. You know the value of delta LA given 5 centimeter, delta LB 25 centimeters, N is given 3. Put the value and you will get the value of X. Delta LA is 5, 1 minus N is 3, delta LB is 25 divided by 3. So this has become minus 2 minus 10. 25 minus 10 is 15. So X will be 5 centimeter. Since it has come positive, so we can say that P point has shifted rightwards from its original position with reference to this line. And this will be your answer. So basically with the linear spring which obeys the Hooke's law, the important is if you select any section of the length after the compression or elongation, the strain in that section will be equal to any other section which has been selected for checking the strain. So this is the core of the concept in this. This is that you can solve it. Hopefully you got the concept. Simple as you can write like this: strain for any section, sections will be equal. If we take AB section, strain in AB will be, if we take BC of that same strain, this will be equal. If you take AB and you take CD section of that strain will be equal. So this is the core of the concept in solving this equation, as solving this question. So hopefully you understood it. Doubts can be clarified. So students, let's close the class for today. Thank you.